In today's lesson, we are going to see a short introduction to the version control system. So, the official definition of a version control system is, in software engineering, a version control, also known as revision control, source control, or source code management, is a class of systems responsible of managing changes to computer programs, documents, large websites, and other collection of information. Version control is a component of software configuration management. In a language that all we can understand, it's a software that allows people in a team to work together in the same project. It's not a magical software. It doesn't perform miracles. It doesn't magically organize the team to work together. It's just a tool to help. This software keeps track of the progress and restores it if we break something. There are plenty of solutions, software solutions to keep track of the software, to do the version control system. But we are going to highlight just the three most popular. The most popular by far is Git. This version control system is used for any kind of software project. It's not only used for just game development, but for the traditional software development. So when you learn about Git, you will be able to use it anywhere. Perforce, it's a software version control system used for big projects that handles really well huge files. I used Perforce in one of the companies I work for, and we had to deal with really huge assets, and it was really a good tool with good integration with Unity. And the last one that I am going to mention would be Plastic SMC. And this is an in-house tool produced by Unity. I also had some experience developing, using plastic in order to control the code. And yes, it's an interesting solution that it's also quite used, but not as much as Git. So we are going to try to do a really short introduction to the whole Git version control system. We are not going to go deep into it because it can get pretty complex. So what we are going to do next is just to clone a repository and do some branches and merge these branches into the master. So what we are going to do is just to start by the first step, that would be to create a repository. In order to create a repository, we have several platforms where you can upload your code. And one of them is GitHub. Okay. So what you are going to do is just to create an account in GitHub. Okay, and get your credentials, and the next step after that would be just to download and install Git. So go to the link and download Git. Okay, get your version and install it. After that, you are going to download and install source tree, that is just a visual front end to perform actions in Git. I know people that prefer just to use the command console in order to perform Git operations, but most of the people will prefer a more visual way, just to commit the progress, check the progress, revert the changes. So you can go really deep into Git operations, but this first introduction is really going to be really simple. Okay, so download the source tree, and after that, just log in with source tree with the account you have created before with GitHub, and the final result would be like this. Okay, you have the source tree front end to perform operations in Git, and you have proceed to login with your credentials. Okay, so here you would have your credentials right here. They are hidden right now, but they are my credentials, and you should have also your credentials right here. So once we have installed all the necessary tools and login with our credentials, now we can proceed to clone projects, okay, clone repositories. And what we are going to do is we are going to clone a repository I made, okay, a public repository that you can clone from this link. For the moment, just click on the link, open the link, and you should see here the repository I created for the course. Okay, and this is the progress that we have done so far, and how you can clone the code so you have a copy in your hard drive, so you can work on your hard drive and then commit the progress on the repository. Well, there is here the option of code, and here you should select HTTPS and copy the URL. Okay, now back to the source tree. What we can do is this option that allows to clone. We specify the path to the repository, okay, and we specify a path, okay. I have previously cloned the repository, so I already have it here, okay. So I would choose a path for the sake of testing new path, and I would select folder, and finally I would press clone, and the process of cloning will start. Okay, once we have cloned the project successfully, so let's try to identify the main sections of the tool, of the source tree. Okay, so the most important thing that you should be aware is in the section branches. In the section branches, eventually you'll have multiple entries, but there will be only one highlighted in black. Okay, in this case, right now the one highlighted is master, is the master branch. But eventually you will have, as we are going to see in this same lesson, that we will work with different branches, you will have multiple branches there, and in that branches you will be able to work in your code without colliding with other people. And after you finish with your work in your branch, then you will be able to submit this branch, this progress that you have made into the master, or into the branch where it came from. Also things that are important. If you want to know what branches do we have on our repository, you can select with the right mouse click, fetch from origin, and here will appear a list of the existing branches. From there you can double click in any of them, and you would be able to jump in your code to that specific branch. Okay, so the most important part in this case has been to identify the branch where you are, and that you can switch between branches in this section right here. So going back to the lesson, each branch is a copy of the base branch where each employee, programmer or artist will work freely without interfering with the work of the others. Another section that it's important to know, it's the section of history. When you select a branch and you select the history, you will see the history of changes. For example, let's select an entry and let's see what has been done for a particular progress. Let's select the entry that says that use of enum for declaration, that is this one. Okay, So when you select this entry, you will get the information related to what have been the changes that the person who has worked on that particular task has made for this specific commit. Okay, and you will get that information right here. First of all, here you will have a description that each programmer has specified when committing his progress into the branch. And here you will get the files that have been modified. Okay, and on the right side of the screen, you will get the changes that have been made from the previous version. Okay, if you recall, let's go with the game controller. If you recall, when we were working with the game controller and with state machine, we defined the states as constants. Okay, there is a better way to do that instead of using constant. That is by declaring an enum type, and in this enum type we declare the range of values that we are going to get, and using that enum type to define our state machine. So the state will range between only values inside this enum. Okay, and that's the change that I have done in this particular task, in the task I have highlighted here. So I have changed it from using constants to using an enum type for the declaration of the different states. Okay, and I have after changing that in the code, in the instances where I was using, I am now using the new enum type with the right information. Okay, I have replaced on all the places that needed to be replaced using the new enum type. And I have done also the same for the camera controller, for the player, for the NPC, and also for the enemy. Okay, so thanks to checking the history, we can get the information about what has been changed and review it to check that if it's correct or not. So let's try to learn by example, by doing something together. That is to going through all the cycle from the task we need to do through the creating of the branch, doing the progress, committing the progress done in the branch, finally merging the progress into the master. Okay, the task that we are going to do is to convert the animation constants to enums in the same way that we have done with the states. We will create a branch from master, and we will call it animation enums. Next, on the source tree, we are going to refresh the existing branches to switch to that particular branch to implement the task we need to do. Once we have switched to that particular branch, we will be able to work freely without interfering with our colleagues. We will implement the necessary changes to complete the task. And once we have implemented the whole thing, we will review it, commit it, and push the changes, and finally merge it into the master. So let's start with the first step, that will be to create the new branch. You can create the new branch just typing here the name of the new branch. In this case, it's animations enums, and press right here, and the branch from the master will be created automatically. Okay, now this is the branch from that we have just created. Now, if we go back to the source tree and we press a right mouse click, fetch from origin, a new branch has appeared. Okay, what we need to do is let's close the the Unity editor of the project if we have it open. And if there are changes made, for the moment you can discard them. One thing that I have to explain, when you make progress, the files highlighted with the icon in yellow, it's because they have been modified, okay? And the ones with the icon in this kind of blue are because they are new files, okay? For the moment, we need to discard any change because so far we haven't done anything right here, and that were just files that were auto-generated by Unity. And we can leave it, the new files are right there, because in theory they are not going to collide when we switch to the new branch. So now that we don't have any modified, any entries with the yellow icon there, we can double click in the branch, press OK, and now you can see on the section branches that there is a new entry highlighted in black. That is animation enums, that is our branch. So now we are on this branch, on the branch that we have created, and we can proceed to work. Okay, so we open the project. And just do the changes that this task is about. So converting the animation constants to enums. So we have here the animation constants, and we have to do the same that we have done for the state. So go ahead and do it. And the changes done should look similar to this. We have just deleted the constants and created the enum type with the states, with the different animations that we had as constants, and we have replaced them in each time that we were using the constant. Now we are using the enum type. Okay, and we have done these changes for the three elements who have animations, that is the enemy and the NPC and the player. Okay, and if everything is right and we go to the Unity project and press play, we should get exactly the same behavior as before. Okay, so the animations are being triggered in third person. Okay, the enemy is going to stop and stay idle right now and attack right now. Okay, everything seems to be working. So now we can go back to source tree, and we should have noticed that in the section where it says unstaged files, we have several modified files. in between the several modified files, we have the ones that we have modified. If we select them, we can see the difference from the previous version, the changes, the exact changes that we have done. Okay, so what we are going to do is just to commit the changes that we have done to complete our task. Okay, when you work on a team, you should only commit the changes related to that task. Why I am not committing these changes? Because most of these changes are related to local settings, and committing the local settings could mess around other people's configuration. You should always commit the changes that you have made in order to complete the task and nothing else. Okay, especially not configuration, local configuration files. So once we have selected to stage these files, the next thing that we need to do is to describe the change that we have done. In here, in this section here, we can specify the description of the changes that we have done. Converted the animation states from constants to enum type. Okay, so the next thing that we are going to do is to press commit, and this would be the first step, and the next step is to push the changes to the branch. So we press push, and we finished with the upload of the changes to that branch. Okay, so now that we have completed the task, the next step would be to to merge this branch into master. So let's switch to one screen. Okay, and in here, in the selected branch, you can see that a new option has appeared: compare and pull request. The pull request is the operation by which you are going to be able to merge your branch, the progress that you have made in your branch, into the master, or into the branch where it comes your branch. I won't go into the details, but there will be several levels of branches, and you won't be working directly against master in professional development companies. You will have some intermediate branches in order to avoid break something that it's meant to be stable, like the master. Okay, so let's keep it simple. Let's create this pull request to merge the changes into master. And well, just to place a description, we can specify a description, or for the moment we can leave it empty, only for the sake of testing. And here it will be shown if there are collisions, if two files cannot be merged automatically. I won't be entering into details of this part because this is far way advanced, but consider that eventually you will have to deal with collisions, okay? But for the moment there are no collisions because I am the only one working on this project right now, and well, there are no previous changes from other places, so I can approve this pull request. I confirm it. Okay, and the pull request has been successfully merged. Okay, so now if we switch to the source tree and let's discard these local changes so we can switch back to master. Okay, let me close Unity project. And now if we switch back to master, now here on the master we have to make sure that we have pulled the latest changes. Okay, so what we are going to do is two steps: to fetch, to check if there are changes to pull, to bring to our local copy, and of course here there are changes, So we can pull these chains into our master branch, into our copy of the master branch, and now if we open the project, we should see in the current copy of that we have of the master branch locally that the changes related to the animation states converted to enum types are there. So as you can see, we are on the master branch, and the change, the implementation that we have done related to the animations is also there. So this has been a really basic overview of the working flow that is to work with a version control system. When you enter in a software development studio, you won't have to care about your own branch and minor collisions, and it will be the person in charge of approving the pull request that will be the lead programmer who has a deep knowledge of the project and has plenty of experience dealing with collisions, the one that will be in charge to review your changes, ask you to change things if it's necessary to change them, in order to finally accept the pull request. Okay. So what we are going to do now is that we are going to go through all this cycle, all these steps that we have done just once for one task. We are going to do it for all these tasks that you can see right here. And we are going to do it using Trello. Okay, Trello is, well, just a very basic way to keep track of the tasks that are doing a team of players. And well, every time that we are going to deal with a task, we will be assigned to a task. Okay, for example, this first one, I am assigned to this task, and then I am going to say, okay, I will start doing this task. After that, I will create the branch, I will switch to that branch, I will make the progress, and when I complete the progress, I will merge the progress into master, put this task to done, and go for the next one. And I will do that for all the tasks. Finally, I need to say that I won't be talking too much, and I will only explain when I implement a feature the code that I have done, and anything else. So in your site, what you can do is just to do the same as I am doing right now, but with your own repository. Create your own repository and do the same steps that I do in your own repository with the code that you have done so far. So I am going to start right now, and you can do it by yourself, so do it. So the implementation should look like this. What we have done, we can see it just in the source tree. We have started by creating the new state. Okay, look to waypoint, and when we update the waypoint, that it's in the state to update waypoint, what we are doing here is we check if the new waypoint is of the type look, and if it's of the type look, we are changing the state to the new state where we will look to the position we want to look. Okay, the position specified in the waypoint. So this is for the part of the structure. Also, we have replaced the state constants by an enum type. Okay, and the other change has been just right here, just to add a new value in the enum type of actions available for the patrolling. And we can proceed. Finally, we have made changes on the level, and on the level what we have done is just to use this new action. For the enemy, we have created a new waypoint, a new entry in the array of waypoints, of actions, and we have set that to look. And we have set the sphere where it should look the enemy right there. And the other change has been on an NPC, where we also have used the look action and with the target that we have set right there. Okay, so next what we are going to do is just to select the changes that we have done, stage them, describe them, commit them, and if you happen to have this flag selected, they are automatically pushed. Okay, so we don't need to push them. Okay, now we can just merge. So if we go to our repository, we have this entry that this branch has had some changes. And since we already did the feature, the task, we can proceed to merge all these changes into master. Okay, so we are going to create the pull request. The system is checking if there are collisions. Since I am the only one working in the project, there are not going to be any collisions, and we finally confirm the merge, and all the changes are now in master. Going back to Trello, we can complete this task by just dragging it from here to done and go for the next one. For example, this one. Implement a summary for the win and lose screens. Okay. So now what we should do is to go again through the whole process. So we will create a new branch for this feature, and we will implement this new feature in this new branch. Okay, and the changes that we have done, first of all, on the prefab win screen, we have created a couple of text fields. We have named the text fields in order to identify them for the use intended. So here we will place the number of enemies that we have killed, and here we will place the number of coins that we have collected. In the codes, what we are doing is, well, we have declared these two public member variables that we make reference to the previous text fields created, and in the start method we are setting the text value of that two text fields with the information we want to show. Okay, on one side we were already getting the number of enemies dead, a counter that we were increasing with this event enemy dead, and we are just getting that information with a new getter. And for the case of the coins collected, well, we have created a new private member variable, a new event that is dispatched when you collect a coin. Okay, here you collect a coin, destroy a coin, and you are sending this event that the game controller is listening, and it increases this the member variable. Then later you can get that information to display it in the summary of the win screen. Okay, so next thing that we are going to do is just to commit the changes. Okay, so on the win screen, on player, on game controller, on system event controller, and on screen win. These are the changes for this specific task. We stage them and we proceed to describe the change, and we will commit the change now back to the repository. We know that summary win-lose, the branch summary win-lose has had some changes, okay? So we can proceed to create the pull request to merge the changes into the master, okay? There will be no collisions, so we can approve the merge, and the changes have been integrated in the merge, okay? So we can move this task from doing to done. So next thing that we are going to implement is the ability for the player to jump and the animation to jump. So we would go again with the whole process. So the code should look similar to this. First of all, we have implemented our method jump. And inside this method jump, what we are doing is checking if we are touching the floor. We will keep that information in a private member variable. If we are touching the floor, we check for the designated key to do the jump. In this case, I am using spacebar. And if we have detected that the player wants to jump, then we change the animation to animation jump, set the variable to false, so we are not touching the floor anymore, and we apply a force in the direction up. Okay. For the detection of the collision with the floor, what we have done is using onCollisionEnter, a method that it's inherited from monoBehavior. Okay, and this detects the collision between two colliders with the property is triggered to false. Okay, so we are detecting collision between the player, and we are checking if the collision is with the floor. And we have created a tag in this case. So we have created a tag for the floor. Okay. So if the player collides with an object with this tag, it's that it's colliding with the floor. In fact, let's put the tag floor in other objects that we can consider like floor. This one, like this one, this another one. And now if we proceed to play, even the walls, we can try to use the walls as floor. If we proceed to play, we should also be able to jump when we are landing on that surfaces. Okay, so if we land here, now we can jump again because we are colliding with this cube. That this cube is tagged as floor, so the player can do another jump. Okay, so once it has detected the collision with the floor, we are changing the animation. In the case that we are on the state of walking, we change the animation to run. If we are not in the state, we change the animation to idle. And we set the variable to true in order to process the next jump. Okay? And for the part of the animation, what we have done is just to create a new animation data, a new state, this jump state. We have used an existing animation for the 3D model that we are using, and we have defined the transitions, and we are using a new ID for the transition to jump. So the only thing left to do is just to go through the source tree, select the changes we want to okay. These are the changes that we have made to implement this task, this feature, and the tag manager, because we have created a new tag. Okay, so with these changes, we specify the description, we commit and push, and now we can go back to the repository where we will be able to create the pull request to merge all the changes into master. There will be no collisions. We are going to approve the merge. The merge has been successfully done and closed. Okay, so now we can go and into the trail and move the task from doing to done and go for the next one. Create moving platforms. So what we have done, first we started just by creating this platform. So we started by creating just a cube. We resized it to the size we wanted, and we added the patrol waypoints script in order to use this behavior in this component. Okay, but the patrol waypoints required some changes. Okay, in order for the patrol waypoints to run its logic, remember that when we were using it in the player, in the enemy and the NPC, we were triggering the behavior by just calling this method activate patrol. In this case, we have created a public member variable that allow us to customize it through the inspector. And this public member variable, this boolean, allows us to auto start the behavior. So if this is set to true, then automatically, as soon as it starts, it will activate the patrolling. And the next thing that we have done is that in order to be able to be in a moving platform, we have to do some changes, and that's what we have done with the script platform. With the script platform that we have attached to all the platforms that we have created here, what it's doing is that when there is a collision with the player, it changes the parent of the player to the transform of the same platform. That way, we are moving alongside the platform. Okay, and also we have to make another change, that is this one. Instead of moving with the rigid body, we will have to move with the just moving directly the position of the transform, because this won't work for this particular case. Okay, so we have to make this change in order to be able to move inside that platform. And when we leave the platform, the parent of the player returns to null. Okay, we are outside the platform, so we are back where we started, and we restore the rigid body in order to move the player through the rigid body. So finally, what we have done is just to create both platforms, one that moves vertically and the other that moves horizontally, but it doesn't matter the direction, because any platform will move through the waypoints. So let's just make this test. For example, let's put this right here and make another waypoint between these two ones, just to check that it's behaving as we expect. So this waypoint will be between this and this. Okay, changing the waypoint here, we will use 5 waypoints, and the transition should be done between the 1 and 2. So the transition would be right here. It would be to platform 4. It would be 1, 2, 4, and then 2, and then 2, and then. So if we check again, now you can see that platform is going down until it reaches the waypoint. Okay, it has reached the waypoint, it goes up. If we go and jump into the platform, we will be moving in the same platform. So let's go to that platform. Okay. Okay, now we are going down with the platform, and we should be going up any second. And we are going up. Okay, so the system is working. So the next thing that you need to do is just to commit the changes, merge into master, and go for the next task. So the code should look similar to this. What we have done is first just to keep track of all the coins, and we have done that by just looking for all the objects in the scene who has the component coined. And with that information, we have created a private list where we have added all the coins. Next, we have created the listener for the events, for the system event controller. And we are keeping track, we are listening for this specific event coin collected. Every time we receive event coin collected, we get the coin and we proceed to remove it from the list. Finally, since we want to check that the game the level can finish when all the enemies are dead or when all the coins have been collected, we have created this public function that returns a boolean that checks if any of these two conditions are met. If any of these two conditions are met, in the game controller, for the transition from game running to the state win, we check that function. So next, what we should do is go through all the process of committing the changes, merging, and going with the next task. And the code should look similar to this. What we have done, we have started with the enemy. We have checked in the state, in the change state, when it's changing the state to the state die. In that moment, we are checking if there is the patrol waypoints component. And if there is the patrol waypoints component, we proceed to deactivate the patrolling. We have also noticed that the area vision detection is also there, so we want also to destroy it. So that's why we have created this method right here that just destroy the visual area. Finally, we have also applied the changes to the NPC in the same change state when it's changing the state to die. Now we can go through all the process of committing the changes, merging, and going for the next task. And the result should look similar to this. First of all, we have started with the area vision detection. And what we are doing is, in the moment that we are checking if the target is inside the detection area, first we check if the height is inside the range we have defined. We have created this public variable member that we can customize through the inspector. And we are just checking the distance, the difference between the height of the component who has the area vision detection and, in this case, the player. We get this distance of height, and if this distance of height is inside the detection range height, then we can proceed to do the checking if it's inside the detection range. We have done not only for the detection for the target player, but for other targets like the enemy and the NPC. Here we are also checking the height between the current object who has attached the area vision detection and the enemy or the NPC. Next, what we have done is that for the case that the enemy or the NPC doesn't have the component area vision detection, we need to also check that that height, that distance between the position of the player and the position of the enemy or NPC. And to do that, we have created at the level of avatar a new public float, height detection. And when the NPC or the enemy are going to check if it's inside the detection range, they are also going to check if it's inside the height detection. Okay, so we are checking, okay, it's inside, the distance is close to the distance detection. If it's close, then next we check if it's in the range of the height detection. If it's in the range of height detection, okay, we return true, or else we return false. And we have done all of this for all the places where we are checking the detection, both for enemy and NPC. Okay, so finally what we need to do is again to go through all the steps to commit the changes and merge it into master. So go ahead and do it. and the result should look similar to this. What we have done is that first of all, we have created on the avatar level a new public member variable that will make reference to the text field where we will display the remaining life, the current life of the avatar. After that, in the start method, we proceed to initialize it with the current life. And every time we decrease or increase the life, we update this text field if it's there. Okay. Next, what we have done is just to for the enemy, we have created the canvas with the text field. We have changed the canvas to wall space coordinates because this is going not to be just a UI interface, but something that is going to be in the wall space. So we check the wall space. And we adjust the size and the position so it's more or less just above the enemy. The first test that we have done happened that the text was only facing in the direction that was facing the enemy, and we were interested that this text will face always the player. So what we have done is just to implement this component script that will rotate towards, in this case, towards the player. We have set the target in order for the object that this component is attached to rotate towards that element, and we have added that element to the text field in order for the text to be facing always the player. What we have done next is, well, just to go through all the enemies and the NPCs, placing the text field and setting the reference to that specific text field. And the only thing left to do is just to commit the changes, merge it into the branch, and go for the next task. So what I have done has been, I have created a new script. This one is a static script. That means that it's going to be accessible from anywhere from the code, and it doesn't need to create an instance of this script in order to take advantage of the methods that are implemented right here. Okay, so in this script utilities, I have been placing methods that could be used in multiple places. One of the most evident ones has been the method getDirection, that it's being used in multiple places, and it gets the directional vector from an origin to a target. And this method is being used in as I said, in multiple places. So it's a good method, a good function to put it on the utilities script. Another methods that I have detected that they could be used in other places are these two ones: is inside cone and draw area vision detection, that even though they were used in area vision detection, we can place them as static methods, because maybe in some other situations we could be interested to use them, both for detecting what's inside a specific area, or to draw a specific polygon. So the only thing left to do would be just to commit the changes. And with this last task, we have completed the task I proposed for you to do. I have done it myself. What I wanted to show you is a little bit of the workflow that all developers around the world are using to face the challenges that mean to work in a software development project. This has been just a really tiny introduction. We will go deeper in later lessons about how the work dynamics inside a team work.